Hello students, welcome. Students, today we will discuss radius ratio and radius ratio rules for ionic crystals. Students, in ionic crystals, the constituent particles are cations and anions. And in ionic crystal, both, that is cations and anions, they are arranged in a regular manner so that electrical neutrality of that ionic compound is conserved. Means positive charge in the crystal should be equal to the negative charge. So the first point which we have discussed is that in ionic crystals, constituents have regular arrangement so that the electrical neutrality is maintained. Now students, second important point about ionic crystals is that जनरली एनाइंस का साइज बड़ा होता है. सो जो बड़े साइज का आयन होगा वही लैटिस साइड्स को ऑक्यूपाई करेगा. सो इसका मतलब हुआ जनरली द एनाइंस दे अडॉप्ट अ क्रिस्टल लैटिस. दैट मींस they adopt either CCP lattice or FCC lattice or HCP lattice, or it can be any arrangement. So generally anions, they adopt the lattice, while cations, now students, this you know that cations are relatively small in size. So cations being small in size occupy voids. Now students, when we say they occupy voids in three-dimensional lattice, they occupy either tetrahedral voids or octahedral voids depending upon their radius or their size. So but now students, this is very important point to remember that किसी भी आयनिक क्रिस्टल में ये जरूरी नहीं है कि कैटायंस सभी voids को ही ऑक्यूपाई करें. So this is very important that it is not essential for all the voids to be occupied by cations. अब कैटायन कितने voids ऑक्यूपाई करेगा किसी भी आयनिक क्रिस्टल में, स्टूडेंट्स, ये डिपेंड करता है उस आयनिक क्रिस्टल के केमिकल फॉर्मूले पे. So this is very important that number of voids occupied by the cations depend on the chemical formula of ionic compound. और vice versa आप ये भी कह सकते हैं that if number of voids occupied by the cations are known, we can predict the chemical formula of that ionic solid. So students, एक बार फिर से रिपीट कर रहा हूं कि किसी भी ionic crystal में voids कितना ऑक्यूपाई होंगे by say the cations, ये डिपेंड करेगा उस ionic crystal के केमिकल फॉर्मूले पे. या फिर वाइस वर्सा हम ये भी कह सकते हैं दैट अगर हमें ये पता हो कि कैटायंस कौन से वॉइड्स में प्रेजेंट है, देन हम केमिकल फॉर्मूला भी उसका प्रिडिक्ट कर सकते हैं. सो स्टूडेंट्स, नाउ द नेक्स्ट पॉइंट अबाउट आयनिक क्रिस्टल्स इज दैट स्टेबिलिटी ऑफ आयनिक क्रिस्टल डिपेंड्स ऑन coordination number of the ion. So stability of ionic crystal is expressed in terms of coordination number, and students, coordination number of ions in turn depends on radius of cation relative to that of anion. So coordination number कितना होगा ions का, अब ये डिपेंड करेगा cation और anion का radius में क्या रिलेशन है. Now generally students, we say that if radius of cation in relation to the radius of anion increases, means अगर cation का radius in relation to anion अगर बढ़ता है तो coordination number भी बढ़ेगा. So this is very very important point. अब मैं इसको students diagrammatically आपको समझाता हूँ. I have, this is cation, so this is cation and these are anions. So now these bigger ions are anions, the small ion, and this is occupying a void, and see, all the ions are touching, means all the anions are touching this ion. So coordination number, here we say it is how much? 3. So this is a stable arrangement. Now listen students, एक stable arrangement में cation anion contact होना चाहिए. And one more thing, or we say that एक stable ionic crystal में all the cations as well as anions should touch each other. Now students, suppose अगर रेडियस ऑफ कैटायन बढ़ता है, से मैंने अगला एक डायग्राम बनाया जिसमें मैंने केटाइन का रेडियस बढ़ा दिया, एनायन का से उतना ही रखा है. नाउ अब जब वो उसका रेडियस बढ़ेगा तो इससे एनायन एनायन कॉन्टैक्ट अब नहीं रहेगा. एंड नाउ स्टूडेंट, दिस इज नॉट अ स्टेबल अरेंजमेंट. अब ये स्टेबल कब होगा? जब फिर से आयनिक यानी एनायन एनायन कॉन्टैक्ट फिर से हो जाए. अब उसके लिए क्या करना पड़ेगा? अब मैं और एक एनायन को इंट्रोड्यूस कर सकता हूं. क्यों? क्योंकि बीच में काफी जगह है. सो व्हाट हैपेंस दैट व्हेन रेडियस ऑफ केटाइन increases in relation to radius of anion, now see what happens, that there is more space, that means more spheres or more anions can be added. So अब पहले 3 थे, अब फिर से उस anion anion contact और anion cation contact को मेंटेन करने के लिए आपने देखा that एक और anion को इंट्रोड्यूस कर दिया. and now see the coordination number increases. So when we increase radius of cation in relation to anion, coordination number increases. So now this is again a stable arrangement. But students, suppose अगर अब मैं इसको और बढ़ा दूं, radius of cation और बढ़ गया, so उससे क्या होगा? anion anion contact फिर से टूट गया. and again this arrangement is what? Not stable. But this anion anion contact now again can be maintained. But how? We can now introduce more spheres because we have lot of vacant spaces in the crystal lattice. So now say I have introduced 2 more anions. ठीक है? They are in an octahedral arrangement and the space between them is then occupied by this larger cation. So what we see is that now the coordination number increases to 6. So very simple fundamental is that as radius of cation in relation to the radius of anion is increased, the coordination number increases. Say पहले 3 था, now it is 4 and then it becomes 6. So the arrangement also changes. Now ionic crystal का arrangement भी change होगा. Initially say we said the arrangement of anions around that cation was say trigonal, then it is tetrahedral, now it is octahedral. Now students, all these results, they can be better described in terms of radius ratio. So students, now I will tell you what is radius ratio. Now students, what is radius ratio? So students, as the term suggests, radius ratio is ratio of radius of cation to that of anion. So radius ratio is radius of cation, which we denote by RC, to the radius of anion, that is RA. Now students, from radius ratio in ionic crystals we can predict coordination number of ions as well as we can predict the structural arrangement of ions in ionic crystal. And this relationship between the coordination number of ions, structural arrangement and the radius is called radius ratio rule. So students, I have a tabular arrangement. Now see, in this table first column is radius ratio. Next, from radius ratio we can predict coordination number, and then from coordination number we can predict crystal structure. Now students, on calculating radius ratio, that is radius of cation to that of anion, if the value is in this range, that is 0 to 0.155, student, the coordination number will be 2 and crystal structure is linear. Hydrogen fluoride crystals, they have this arrangement. Students, if radius ratio lies in the range 0.155 to 0.225, the coordination number of the cation in that arrangement will be 3 and the structural arrangement of the anions around that cation would be trigonal planar. The boric anhydride crystals have such arrangement. Thirdly, if the radius ratio lies in the range 0.225 to 0.414, the coordination number of cation will be 4, or the coordination number of ions is 4, and the relative arrangement of the other ion around that ion would be what? Tetrahedral. Zinc blend crystals have such an arrangement. Now students, if this radius ratio lies in the range 0.414 to 0.732, then the coordination number will be 6 and the crystal structure is octahedral, and rock salt, that is sodium chloride crystals, have this arrangement. Lastly students, if radius ratio is in range 0.732 to what? 1, then the coordination number is 8 and the crystal structure is cubic, and student, it will be accurate or precisely it will be body centered cubic, and cesium chloride crystals adopt this arrangement. So students, this table of radius ratio is very important. इस टेबल से क्वेश्चंस कॉम्पिटिटिव एग्जाम्स, बोर्ड एग्जाम्स दोनों में से आ सकते हैं. सो आई एम गिविंग यू सम प्रैक्टिस क्वेश्चंस आल्सो. सो फर्स्ट I have practice question. Now students, see, if radius of cation, that is A positive ion, is 169 picometer and radius of anion, that is chloride, is 181 picometer, sorry, B negative ion is 181 picometer, predict the structure and coordination number of A positive ion. Now students, this is a very simple question. We'll find radius ratio. And what is radius ratio? Radius ratio is radius of cation to radius of anion. Radius of cation is 169 picometer and radius of anion is 181 picometer. Now students, when we solve this, we get approximately 0.93. Now students, see, this value is in the range 0.732 to 1. So now see, this is in the range 0.732 to 1, which means the coordination number would be what? 8, and the structure would be body centered cubic. So this is our answer. Now question, we have another question. Students, this question was asked in NEET 2016 exam. The ionic radii of A positive ion, B negative ions are given 0.98 into 10 raised to power minus 10 meter and 1.81 into 10 raised to power minus 10 meter. The coordination number of each ion in this crystal AB is. Now again students, will find radius ratio. And what is radius ratio? Ratio of radius of cation to anion. Cation has radius 0.98 into, so this is 0.98 into 10 raised to power minus 10 meter. Anion has radius 1.81 into 10 raised to power minus 10 meter. So students, solving this we get, so this is 98,181 and approximately say this is 5, so 0.5 approximately. Now this lies in range what? It is 0.5, so 0.414, so this is in the range 0.414 to 0.732, and this implies what? Coordination number of each ion would be what? 6. So correct answer is option A. So students, this was radius ratio rule. And one more thing students, the highest radius ratio value can be 1 in crystal structures, because in crystal structures radius of cation, if exceeds radius of anion, then the arrangement would not be will not be that stable. So the maximum radius ratio which can be obtained in ionic crystals is 1 for BCC structure. Now students, we will discuss crystal structures of some simple ionic compounds. Students, so the first type of ionic compound which we are going to discuss is rock salt structure, or NaCl. We have one example. So in rock salt structure, student, this is a very important topic. Now in rock salt structure, chloride ions adopt CCP or FCC lattice, which means chloride ions are located at, or they are present at, all the corners and face centers of the cubic unit cell. So here I am representing chloride ions by a red dot. So we have, see, chloride ions at the corners, and then we have chloride ions at the face centers. Now students, sodium ions occupy all the octahedral voids. So sodium ions kahan hai? Octahedral voids mein. Now students, we know this, that what is the location of an octahedral void? So student, octahedral void is located at the body center of the cubic unit cell and at the center of edges. So these blue dots are actually the what? Sodium ions present in octahedral voids. So octahedral voids कहाँ होते हैं? Body center और edge के centers पे. So student, this is the relative position. Chloride ions adopt FCC lattice and sodium ions occupy all the octahedral voids. Now second important point in this structure is that number of chloride ions per unit cell. Student, chloride ions since has FCC lattice, and we know that face centered cubic arrangement में number of atoms or ions per unit cell कितने होते हैं? 4. So that is why we have 4 chloride ions per unit cell. Now number of sodium ions कितने हैं? They are also 4. अब ये 4 कैसे हुए? Now student listen, where is sodium ion? Sodium ion is in octahedral void. Now octahedral void हुआ एक body center पे, plus we have 12 at the edges or edge centers, and edge center पे contribution कितना होता है? 1/4. So this is 1 plus 3. So 1 plus 3 is 4. So now students, we have 4 chloride ions and 4 sodium ions per unit cell. Now next important point is how many formula units per unit cell are there? Now students, first what is formula unit? तो मैं आपको पहले ये बता दूं that in case of ionic compounds like sodium chloride, when we write sodium chloride chemically, the chemical formula we write NaCl. But students, let me tell you, this NaCl is not molecular formula. Why it is not molecular formula? Because sodium chloride is not a molecular compound. Sodium chloride is an ionic compound, and ionic compounds are composed of ions, not molecules. So this NaCl does not represent a molecule of NaCl. Instead, we call it is a formula unit. It is a formula unit of sodium chloride. So student, this is a very important point, that this formula of an ionic compound represents its one formula unit. Now students, in one formula unit we have how many sodium ions? We have 1 sodium ion and 1 chloride ion. But per unit cell हमारे पास तो 4 सोडियम है और 4 क्लोराइड है. So इसका मतलब हमारे पास कितने formula units हुए? 4. So we have how many formula units per unit cell? Students, we have 4. Why 4? Because per unit cell we have 4 sodium ions and 4 chloride ions, and since one formula unit has 1 sodium, so 4 sodiums make 4 formula units. Similarly 4 chlorides make 4 formula units. So we have how many formula units per unit cell? 4. Now students, the next important point about rock salt structure is coordination number of ions. So student, coordination number of sodium ion is 6. अब ये 6 कैसे है? This is very easy. Say this is sodium ion in octahedral void. Now student, see, this sodium is touching 1, 2, 3, 4, 5, 6. You may join these and you will get an octahedral arrangement. See, the relative arrangement around the chloride ions around this is what? It is octahedral. So this is a perfect octahedral. So that is why we say coordination number of sodium ion is 6. Now similarly, coordination number of chloride ion is also 6. How? Now this is say chloride ion. ये है chloride ion, या कोई भी आप ले सकते हैं. Say this is chloride ion. Now इस chloride ion के साथ सी एक ये हो गया, this is second, this is third. But similarly, when we extend this structure, this is fourth. When we extend this one, this is fifth. When we extend this, this is sixth. And now you see we have how many? 1, 2, 3 here and 3 on this face. So overall, see, we have how many? 6 what? Sodium ions around each chloride ion. So coordination number of both ions, sodium and chloride, is 6 each. So this was coordination number of ions. Now students, a very important point about rock salt structure जो बहुत बार competitive exams में पूछा जाता है in the form of numericals. This is, now students see, ये जो cubic lattice था यहां से लेके यहां तक, this is edge length of that cubic cell. And now see, edge length, student, A is, now this is chloride ion, this is sodium ion. So assuming that these are touching each other, now interionic distance यानी इन दोनों के बीच में जो सोडियम और क्लोराइड के बीच में डिस्टेंस है, this is D. So A is actually, this is also D. So A कितना होगा? A is twice of D. So I have written here A is twice of D. How it is twice of D? This I have shown. And now students, interionic distance D होता क्या है? Since मैंने कहा ये दोनों टच कर रहे हैं, तो इसका मतलब D is radius of anion plus radius of cation. So this is radius of cation plus radius of anion. So students, ये point बहुत बहुत important है for competitive exams also. So this is the structure of rock salt, or any compound which has rock salt structure will have these features. Now I have some other examples, students. All alkali metal halides have rock salt structure, means उनका structure भी ऐसा ही होगा. There is an exception except cesium chloride. Cesium chloride का body centered cubic lattice होता है, so वो एक exception है. Second, all alkaline earth metal sulfides, that means sulfides of group 2 elements, they also have rock salt type structure except beryllium sulfide. Beryllium sulfide has a different structure. It has a zinc blend type structure. And thirdly, we have silver halides. They also have this rock salt structure, but there is an exception, silver halide. So please remember these exceptions, that all alkali metal halides have rock salt structure except cesium chloride. Sulfides of alkaline earth metals have rock salt structure except beryllium sulfide. And similarly, silver halides, they also have rock salt structure except silver iodide. So this was rock salt type structure. Now students, we have second type of structure which is called zinc blend structure. Now zinc blend is a ore of zinc. So we have common example of zinc sulfide. Now students, what are the characteristic structural features of zinc blend type structure? So firstly, we have that in zinc blend type structure, anions, that is sulfide ions, they adopt lattice FCC or CCP. So that means they are present at all the corners and face centers of the cubic unit cell. So ये red dots आपके sulfide ions है. And where are zinc ions present? So students, zinc ions are occupying alternate tetrahedral voids. That means they are occupying half of the tetrahedral voids. Now students, आपको पता है, in this crystal lattice, we have what? We have 8 small cubes, that is 8 unit cells. So we have 8 tetrahedral voids. आपको पता है वैसे भी FCC में 4 atom है तो 8 tetrahedral void होते हैं. But only half are occupied. So we have half of 8. How many? 4. So we have 4 tetrahedral voids. So these are what? Zinc ions present in the tetrahedral voids. Total there are 8, but since only half are occupied, so I have shown only 4 of them. Now students, second important point is how many zinc and how many sulfide ions per unit cell are present. So since sulfide ions are in CCP, how many are present per unit cell? This we know, 4. And now students, how many zinc ions we have? They are also 4. How? Because zinc ion kahan par hai? They are in half of the tetrahedral void. and half of the tetrahedral void तो total 8 है, but only half are occupied, so we have 4. So we have how many zinc ions per unit cell? 4. And how many sulfide ions per unit cell? 4. ये उनके relative arrangement से हमें लग गया पता. Now अब अगेन वही बात, that एक फॉर्मूला यूनिट जो जिंक सल्फाइड का है उसमें तो हमारे पास एक जिंक और एक सल्फाइड है, बट पर यूनिट सेल वी हैव हाउ मेनी जिंक आयंस? 4. हाउ मेनी सल्फाइड आयंस? 4. सो 4 जिंक और 4 सल्फाइड आयंस से पर यूनिट सेल कितने फॉर्मूला यूनिट्स बनेंगे? अगेन इट इज 4. सो नंबर ऑफ फॉर्मूला यूनिट्स पर यूनिट सेल आर 4. We denote number of formula units by Z. So we have 4 formula units of zinc blend per unit cell. Now students, the next point is about coordination number. Students, this is very easy. Zinc ion कहाँ है? Zinc ion is in tetrahedral void. और आपको पता है every ion which is placed in a tetrahedral void will have a coordination number 4. ये वैसे मैं यहाँ भी बता सकता हूँ आपको. If this is zinc ion in tetrahedral void, so these 4 what sulfide ions, they are in tetrahedral arrangement, और ये 4 sulfide ions जब आपस में अरेंज्ड होंगे टेट्राहेड्रली तो उन 4 के बीच में जो खाली जगह होगी वहां पर जिंक है. सो जिंक इसको भी टच कर रहा है. 1 2 3 4. सो कोऑर्डिनेशन नंबर ऑफ जिंक आयन इज 4. एंड सिमिलरली स्टूडेंट, आई एम गिविंग यू अ लॉजिक. Whenever we have a ionic crystal having stoichiometry 1:1, ठीक है, the coordination number of cation and anion will be same. Like NaCl में भी ऐसा ही था. Stoichiometry was 1:1, that is 1 sodium 1 chloride. So coordination number is 6:6. Why 6? Because वहां पर वो octahedral void में था, but यहाँ पर वो tetrahedral void में तो 4. So अगर जिंक आयन का 4 है तो सल्फाइड का भी 4 ही होगा. अदरवाइज भी आप क्रिस्टल स्ट्रक्चर से भी बता सकते हैं कि हर सल्फाइड आयन के अराउंड ये 4 व्हाट जिंक आयन भी होंगे. नाउ स्टूडेंट्स, देयर आर मेनी अदर कंपाउंड्स which have this structure, zinc blend structure, and we have some examples. Copper halides, they have zinc blend structure. So student, अगर आपको कभी कोई क्वेश्चन आता है जिंक ब्लेंड स्ट्रक्चर किसका होगा, तो रिमेंबर जितने भी कॉपर हेलाइड्स हैं, कॉपर क्लोराइड, कॉपर ब्रोमाइड, कॉपर 1 आयोडाइड, they have zinc blend structure. Now AgI is a silver halide, but I have told you that silver halide में silver iodide का rock salt structure नहीं होता, उसका zinc blend structure होता है. Similarly beryllium sulfide was an exception, उसका rock salt structure नहीं होता है, उसका zinc blend structure होता है. And students, this is very very important point to note that diamond जो आपने +1 में कार्बन के एलोट्रॉप्स में पढ़ा था, has a zinc blend structure, जिसका मतलब हुआ डायमंड में जो कार्बन एटम्स हैं दे आर इन FCC प्लस दे आर इन हाफ ऑफ द टेट्राहेड्रल वॉइड. सो ये बहुत बार इवन नीट एग्जाम में भी ये क्वेश्चन आ चुका है दैट हाउ मेनी कार्बन एटम्स पर यूनिट सेल आर प्रेजेंट इन डायमंड. सो स्टूडेंट, डायमंड में कार्बन FCC में है तो पर यूनिट सेल कितने कार्बन हुए? 4. एंड हाफ ऑफ टेट्राहेड्रल वॉइड मतलब 8, दैट इज ऑल्सो 4. So 4 plus 4, it is 8. So how many carbon atoms are present per unit cell? It is 8. So students, this was zinc blend structure. Now students, please revise these structures because in next lecture I'll discuss some questions based on these types of ionic crystals. Thank you.